Итак, мы начинаем интервью с Гербом Саттером. Экспертами на этом интервью будут Анастасия Казакова из JetBrains и Сергей Федоров из Яндекс.Лавки. So today our guest is Herb Sutter. He is well known for any C++ developer because Herb Sutter is an author, chair of C++ Standards Committee, and a programming language architect at Microsoft. In this live QA session, Herb will answer as many of your questions as possible in the hour. Welcome to the hour broadcast, Herb.
Thank you. Thank you for having me.
Yeah, glad to see you. So,
welcome, Herb. Thank you. Thank you, Pasha. So let's start. I think we can just right now start with a very, very interesting question. So, Herb, do you personally see a language which can compete with C++ in its areas of popularity and finally substitute C++?
So we're starting easy. I have to laugh just because it's a very direct beginning, and so it goes straight to the heart of many questions. But that's a great place to start. So I don't know if some of you may have seen a new talk I just gave at Dev Around the Sun at that event a couple of months ago for the first time, where I talk about the importance of how to succeed with a new product, a new programming language especially. And one of the slides was actually about what would it take to make a successor to C++? So I can actually give you an answer to that. If I can use one slide from there, I can show it to you here. And the key thing is, the three things I talk about in the talk are you have to show the value of whatever the new thing is. It could be a new product, but let's talk about a programming language. And usually it's easy to say in C++ what we want to fix. The complexity and the safety are the two top ones, for example, toolability. And you want to make it available. But the key differentiator, because many languages do those first two things, so D, Rust, and those kinds of languages, they are pretty good at articulating the value and being available wherever C++ is through LLVM, for example. But the one differentiator that I highlight in the talk and that applies here is compatibility. So without going through all the rest of the talk, one of the key things that we've noticed in the Python 2 to 3 transition, in the C99 transition, and in many other cases, is if you don't have strong backward compatibility with the thing that you're trying to replace or compete with, it's going to take you about a decade longer. You may still succeed, but it will take you about a decade longer to do that. And it is very hard to design that back in. So for example, D and Rust have both shipped without being able to be designed to just seamlessly call C++. And that's fine. It will just slow down adoption. And both of them are now trying to, just like Dart did with JavaScript, build back in backward compatibility in different ways through wrappers and other calling convention support and things like that, which is harder to do after the fact. So one of the things that I would say is any language that wants to compete with C++, including that each version of C++ is a competitor to the previous version. The key differentiator that only the next version of C++ has done so far is have seamless backward compatibility, where you can just seamlessly call existing code. You can use it side by side in an existing C++ project. And the holy grail is that you can write just one line of code in the new language, whether that's C++ 23 or Rust or something else, even within C++ source files, and start to see benefit. So that level of compatibility, I think, is important for any new product, including C++ Next as a successor to the current version of C++, which we're doing. We're making a new successor every 3 years. So far, the only language that has successfully displaced C++ in the marketplace is the next version of C++ each time. And so we're going to try to continue being successful at delivering new versions of the standard that way. But to do it, we ourselves have to be compatible. And I think that any successor language that really wants to get traction more quickly will need to focus on compatibility more than has been the case with existing competing languages. That's not to say they won't succeed. They are starting to see some traction in different places, but it will greatly slow down adoption. And so that's something that I have encouraged others who have designed new languages, new systems languages, to try to prioritize the C++ compatibility.
Thank you.
So, okay, thank you. There are currently modern languages that are very popular, such as Rust, Go, or Python, that evolve much quicker than C++. Do you think that C++ can ever achieve the same speed?
So that's an interesting question. Part of the question is it desirable? So definitely C++ is on a slower evolution path. And that's in large part because it's got such a large installed user base and billions of lines of code that rely on it. And in major companies in virtually every industry rely on C++ code. So you can't just go fast and break things. You don't have the flexibility that you do when you have a very small installed base to do that. Having said that, language evolution has been going quite quickly in C++, especially over the last 10 years. In fact, this year we're just shipping a new standard that has at least 4 new major language features in the standard, concepts, modules, coroutines, and those are going to make a big difference in the way people program C++. So we actually are delivering quite a lot. I would caution it's not always desirable to just add things quickly. And there's 2 main reasons for that. One is you've got the big ecosystem that you need to make sure you're compatible with to bring them along. And that's compatibility again, like I mentioned. So you go slower when you're a super tanker. You take the turn slower than when you're in a small sailing ship. But the other reason is it just takes time to design features well that are well thought out and work reasonably well in the spirit of the existing language, and that are absorbable by the community. So, for instance, at Microsoft, I work closely with the C# language designers as well, and we talk frequently. And C# similarly has been adding features at about the same rate as C++ lately, because now they are a large, important language. You don't want to just keep throwing things in, but you want to make sure they have value, that they fit well with the language. And so I think you'll see that as languages get more complete, there's less of a pressure to add new things. You'll still keep adding new things, but you already have such a critical mass of them, there's less pressure, and you're become more aware of the costs of adding things, especially adding things without a strong integration and a clean integration with what was there before. So that's the cost and benefit. And I think as languages get bigger, you also have to weigh the adoptability and also that you don't want too big a language. And it's interesting, not just C++ is dealing with that, but languages like C# that have been around for a few decades now are dealing with the same thing of being very concerned not to try to do too much in the language while still staying nimble to add the things that are important that solve new problems.
Talking about the language evolution, thank you, Herb. And about how the language evolves, like C++ 20, it seems to me now called the most impactful revision of C++ in maybe a decade. And there is a big 4, like modelless, concept, trages, and coroutines. There is spaceship operator, thank you for that. There is std format and much more. So the question is how the committee managed to achieve such a big release. So was it some targeted, dedicated effort, or it just happened occasionally because many things were there?
Well, let me answer that with a picture that you'll also find on the isocg.org website. But if you look at the way that C++ has managed its releases, so this is going back to the beginning of time back in 1980 when Bjarne was working on his own. That first line here is Bjarne working on his own. The second line is the first round of standardization, and then we took a hiatus for a few years. The bottom line currently showing is the C++11 round of standardization. And you'll notice that one of the things we started doing was doing some work off to the side, kind of like in an open source project, doing work in branches, feature branches. And then when the features are ready, then they get merged into trunk. Well, we really followed that pattern in the last 3 cycles. So you'll notice that we ship regularly every 3 years now, C++ 14, 17, and 20. But we've also been doing a lot of work off to the side in these TSs, which you can think of as feature branches. So the model is that the trains leave the station on time. Whatever is ready can be put on the train. And if a feature isn't ready yet, then it just can wait until the next train. This had the major advantage that we actually know when we're going to ship. Back at the top of the screen, we originally thought that the C++ 11 cycle was going to take half as long, and some people wondered whether we were ever going to ship a standard again because we kept trying to do it based on the features. Oh, we can't ship yet because we got to get this other feature on the train. But when the train leaves the station regularly, then it relieves a lot of pressure because you can just say, oh, that's all right. This train is leaving the station. The feature wasn't quite ready. We can just put it on the next train when it's ready, which has increased the quality of the standard and of the features. It's actually let us do more work. And so when you look at C++ 20, if you look at these arrows that merge, you'll see 3 or 4, 5 that merged into C++ 17, and you'll see quite a few major ones that merged into C++ 20. So it's not that we did more work in these last few years, in these last 3 years, than we did before. Rather, it's more a question of that several things, major things that were long pole items we've been working on for, as you can see here in the picture, in many cases, for the better part of the last decade, all happened to finish around the same time. And so they got on this version, this particular train.
Thank you. So it seems we are just lucky enough. Thank you.
Thank you.
Well, but again, we would be unlucky if that happened every 3 years. The community would not be able to absorb, but seriously, the community would not be able to absorb that level of release if we did that every 3 years. So it just happened to be a bit of a chunky, one big lump of a release. A lot of major things got finished then, but that made it the biggest release since C++ 11. And I think it'll have a similar positive impact on the community.
Okay, thank you.
Thank you. When would you expect the wide adoption of C++ 20 among the developers?
So adoption is gradual. When do you measure the adoption? So the question isn't quite like, do you expect 90% adoption, 10% adoption? It's hard to measure. It'll be faster in some areas than others. Embedded systems often is a bit slower to update because they have more dependencies on the compiler that ships with their operating system, things like that. But in general, we're already seeing a good uptake of new C++ 20 features, even though we haven't shipped the standard yet, because compilers have implemented some of those features. But it usually takes a good 5 years before that becomes widespread in the community. And people have dependable compilers that support all those features in all the platforms they care about. They've done the education so their programmers know how to use those features. So we're starting to see it already, but it usually takes a few years before you start seeing the majority of people who are using the latest standard.
Thank you, Herb. And talking about the adoption, I have to ask it. Like C++ Foundation does an extensive research on how the language is adopted. We at JetBrains also do a developer ecosystem research and validate the results against the foundation. And we see a huge adoption of C++ 20 this year. Like for a developer ecosystem, it's 12%, and it's actually much more in terms of the majority features from C++ 20 used if we check the foundation survey. So are you personally satisfied with the result? Do you think it's a good one, or we could do better?
I'm quite satisfied with the result. Again, it sometimes will depend on which industries that you look at. Some will be faster than others, but it's certainly encouraging to see double-digit percentage adoption of C++ 20 features before we've even shipped the standard. I think that's a bit surprisingly high, but it also shows that there's a level of maturity in the features, and that also what we're standardizing largely already has implementations. This has not always been the case with C++. You might remember that when we shipped the first standard of C++, C++ 98, that there were a couple of features that never were implemented widely, and that the standard as a whole, it was 5 years before there was a fully conforming implementation. Now we regularly have fully conforming implementations within a year or two of the standard being shipped. In fact, in this case, for C++20, it looks like we will have probably more than one full conforming implementation in the major compilers in the same year the standard is published, which is something we've never had before. And it's largely because many of the features that we're now shipping in C++20 have already been implemented even before they were standardized in compilers, much more than we did in the past. And that makes them available faster once they're standardized, of course. It makes them available for people to try even before they're standardized, but it also increases the quality of the feature. So it's very nice to see that happening as the compiler developers are largely tracking the current working draft meeting by meeting and not just waiting for the whole standard.
Thank you, Herb. And are you personally happy with the current C++ 20 shape?
Yes. In fact, this is a milestone in several ways. Here, let me pull up an example of what I mean. And here's a slide that I showed a year ago in the standards committee that really summarized the kinds of things that we were doing. And with all of these major features, and this was in the same week as the anniversary of the Apollo landing, when we had our feature complete meeting last year, looking at all of the things that are in the standard, this is an enormous release. And one of the key things about this release is including the highlighted parts which are in the library. So it's not just that we're evolving the language, but also doing much in the standard library itself, which is even faster for people to be able to adopt, to give them those foundational libraries. One of the key things that I've lost my train of thought. Oh, yes. So one of the key things here is that now, for the first time in C++ history, C++20 actually has every single major feature, except for the minor feature of unified function call syntax. Every feature that Bjarne wrote about in the design and evolution of C++ back in 1994, when we were still early in working on the first C++ standard. Now all of those are part of standard C++. So one way of looking at this is the first release of C++. It's only the third one ever that's been a major release with this many new features all at once, but it is the first one ever that actually fully has Bjarne's vision of what C++ should contain and should be. And that, I think, is a remarkable milestone, including that we're very grateful we still have him active in standardization. And you already had a chance to talk to him here at this conference 2 days ago. So it's great to have him active and to have achieved this milestone, which is in the spirit of what he has always viewed C++ as what it should become.
Thank you, Herb. And with this giant step with C++20, let's move forward. Let's move to those proposals which are now cooked for further standards. So what's the current shape of meta classes? What's your expectations, estimations?
So I have a bunch of proposals that are in flight myself that I've been working on for several years. So knowing, because I had a sneak peek knowing this question was coming, so I thought, I really should give a status update. And so I cut and pasted from notes I have, and I can show you that here. So there's one thing that I did about 5 years ago is I stepped back and I took a look at, okay, all of C++ evolution. What does C++ most need? How can we evolve C++ intentionally in that kind of direction in a cohesive way, so we're making multiple major improvements, but that are correlated together instead of being one-off features? And so several of those that I've been working on have been reflection and meta classes, lightweight exception handling, spaceship, lifetime. And these were designed not as just individual proposals, but as a cohesive way to how can we improve C++ overall for safety, for programmability and usability. But they've been brought to the committee as individual proposals, to one at a time, because we can only absorb so many things at a time. And in order to validate that each one works, can be acceptable to the committee. So one of those was that I started talking about publicly in 2015 was the lifetime rules, static analysis rules for detecting various cases of leaks and dangling in particular. And that is now on track. It is implemented and shipping in the Microsoft compiler in the as a static analysis extension. And it's available in a Clang fork and gradually just starting to have pieces brought into Clang trunk where it's already been identifying real bugs and real projects. Right now, that's only been an informational paper to WG21, but it could also could take the form of a standards proposal in the future. So this one's going well. It's in two compilers, one of them in the shipping compiler and one of them gradually going into the trunk of the compiler. And so that looks promising, and it's finding bugs in real world code. Another piece that came from this work, which was sort of a targeted opportunity, I wouldn't have proposed it on its own necessarily, except that after we shipped C++ 17, the committee continued talking about comparison. So because I had done some design work on that, I offered it to the committee, and thankfully they took it pretty much in its original form. It's now part of C++ 20. They did improve it in two significant ways, adding symmetry for equality so we don't lose the equality optimization, and to have a compatibility bridge to the existing types. But this one actually has already been adopted in C++ 20, which is really gratifying to see. I'm surprised at how quickly it was able to progress and still validate that even though as we were fleshing out details, it maintained its original form, so the design was sound. Metaclasses is the one you were asking about. So when I first proposed it, this required three fundamental advances: compile time programming, which at the time there was some of in Constexpert, but it was still very new and not fully general. It required reflection, which had only started to see some very initial proposals and was definitely an adventuresome bet. And code generation, to then go and actually generate code at compile time to generate more C++ source, which had never been done in C++ before. Once you have those three things, metaclasses is just a syntactic sugar for applying a compile time function that does reflection and generation. But the original metaclasses proposal wasn't just metaclasses, it was also reflection, because we didn't have that yet. Full compile time programming that you could run arbitrary C++ code at compile time, which we didn't have yet. And generation of C++ code, which we didn't have yet. So as this has been progressing, the most important thing is that we've continued adding compile time programming. So that middle layer is almost fully there now in C++ 20. In fact, const eval functions in C++ 20, which are guaranteed to run at compile time, are from this metaclasses work and related papers. But it's directly from the implementation of metaclasses done in Clang by Andrew Sutton and his company from my design that led to const eval and some other features in C++ 20. So that middle piece, compile time programming, is going well. Then the reflection is now one of the 7 priorities adopted by the committee as one of the 7 important things they want to focus on in the C++ 23 timeframe. I don't think it'll quite make C++ 23 even without the current disruption with COVID-19, but it's certainly one of the 7 things that the committee wants to make significant, serious progress on as a priority for C++ evolution. So that's great, because that's now well on track, and that's the major underpinning of metaclasses. In line with that, generation has also been pursued and has been progressing with papers by, again, Andrew Sutton and David van der Voorde and others. So once those 3 things are part of the standard, and they're all well on track, reflection, const eval, and generation, Metaclasses becomes basically a 5-page proposal, which says, oh, you know, all those other things that we were trying to get you to add, thanks for adding them. Now I only have this small proposal, which is a syntactic sugar for applying a compile time function to the class I'm authoring as I'm authoring it as a syntactic sugar. So this one's going very well, but as you see, this is a long lead thing that requires multiple years because it required advances in 3 foundational areas. And it's not often that you want to bite off a project that requires advances in 3 areas so you can build the thing or lose them together. But I hope that it's been helpful to also give a direction to the compile time programming, reflection, and generation as we've been building them with metaclasses as a goal and a use case as to how you would use these things so that we make sure we're designing them with a use case in mind. Lightweight exception handling is one of the newer ones. I've just been, since 2018, bringing that to the committee, and the committee has encouraged further work. Now, this one did not have a prototype yet before I brought it to the committee, unlike metaclasses. And so the purpose of the first round of going to the committee was to understand, is this a direction that they would find acceptable? And we've got initial positive response, including specific technical questions to answer. And so now that we've got that, the plan is to do prototyping work next year. And once we have a prototype in hand, and we've shown that we can actually answer the technical questions that EWG in particular put to us, then I'll bring the proposal back with a prototype and with those technical answers with a refined proposal. So that's the goal there. And then finally, there's one that I've just started talking about this year. The first time I talked about it on camera was in February in Prague, and at the user group meeting there that's on YouTube. And that's about parameter passing and initialization. It's very similar. It uses similar static analysis rules, a subset of the ones from the lifetime work that we've already implemented. But now the next step here, before I bring it as a committee paper, is to build a prototype implementation. But when I do bring the paper, its number will be 708. So the paper already exists, but I would like to have a prototype implementation of this, maybe hopefully in the next year, before bringing the paper to the committee in the next year. So those are the major things I'm working on right now. All of them are multi-year efforts, but hopefully that gives you an answer as to what their current status is. I know you only asked about metaclasses, but I noticed people also asked about most of the others, and so I thought I should at least give a status report on all of them.
Thank you. Okay, so let me proceed here. So as you mentioned a few other proposals, so let's speak a little bit about the lifetime proposal and its progress, okay? So the lifetime proposal, so it seems that the implementation in the compiler is crucial to this like very important change. And however, we see that the implementation is now driven by only 2 developers, if I'm not mistaken. So I mean the Clang implementation, and like of course they do the incredible job here, but don't you think that the lack of resources here slows down the very important feature we might have?
Yes, it can. So there's 2 aspects of this. First, there are actually 2 implementations. Microsoft ships an implementation, which is by the static analysis team at Microsoft as part of the Visual Studio product. So that's the Microsoft implementation. The one you're talking about, which is the 2 developers, Gabor and Matthias, who are the primary developers on the Clang implementation, yes, it's primarily been those 2, but also the thing to remember there is that as we overlap that with the work that Lock 3 and Andrew Sutton and Wyatt Childers are doing, that's actually also, you might have noticed, as part of the cppx.godbolt.org compiler. Those rules are available there. When I last demoed them on stage, they were in that compiler as well. So Andrew Sutton's company is also supporting those. But most importantly, that's all in a fork of Clang, not Clang trunk. As I just mentioned, some of those features are starting now to be upstream to Clang itself, where some of the initial parts of the lifetime rules are now shipping in the Clang compiler. In fact, the parts they did first was some of the type categorization and some of the extensions of existing rules that the Clang implementation had and that the lifetime proposal generalizes, that are just at statement level scope. So they're sort of at a very fine-grained level as a generalization of rules Clang already had in the direction of the lifetime proposal. Because those rules were already there, and because the implementation of the lifetime rules is sufficiently fast to be able to run it during compilation just regularly, those rules have been on by default. And so when other teams that then took new versions of the Clang compiler, even last year, like Google's Project Fuchsia, got the new Clang compiler, they started getting those lifetime warnings without actually opting into anything because they were on by default, and it found a number of bugs in their code, which they have now gone and fixed. So that's very nice to see. But in terms of the developer input, it's nice to see that the prototype implementation is complete enough that it doesn't require a lot of maintenance. And as it goes into the trunk of the Clang compiler, then of course it becomes a first-class supported feature in the Clang community. And we're very grateful for their interest in that, and appreciate the help of all the people who are reviewing PRs and proposals to start getting those features in. Again, that's Clang. There is a second implementation by the Microsoft Static Analysis team, which is shipping as part of our product as well. So that may give you a sense of where the current implementation status is on those two implementations.
Thank you, Herb. I'd like now to talk about the concepts. In CLang, it was implemented by Sar Raz, and well, big thanks to him for getting it there. Thinking more globally, compiler support is an essential part of the new language feature adoption, but quite often it is only driven by one or two enthusiasts. Does it feel like C++ suffers from lack of force here?
If the question is resources for implementing standard features, I think it's true that most features, as they're being standardized, there's a prototype by one or two people. The purpose of the prototype is to show feasibility. Once you start getting to doing a commercial implementation, then yes, it can be a single person, as the case of Clang or of GCC for modules there. But I think the right way to look at it is that it now becomes the product team or that compiler implementations community that is saying, hey, this is a standard feature, we are going to implement it in the standard. And for example, for the spaceship operator in the Visual C++ team, that work was largely done by one person, Cameron DeCamera. Hi, Cameron, and thank you for that. It was definitely a team effort. There were, the Visual C++ team all in as a group of about 150 people, but it only took one person to implement that. It was definitely a team decision to budget for it, to assign that work to that person, to do the quality assurance, documentation, the customer support, and all of the things that go with it. So when you look at implementing a feature, look at the intent of the team. Even if it only takes one or two people to implement it, it is in a production compiler for a supported non-experimental feature. It is very much a team effort. And never think a feature is done just because one person or two people, whoever the implementers of that feature were done and checked it in. That's the beginning, not the end, because then you have the whole quality, the backward compatibility, the training of customers, the support of customers is a very large endeavor. When you've done your first check-in and then your unit tests run, that's the beginning. It's not the end. But often that first part can be done very well by a couple of people. Some of the larger features, like modules, have taken more resources. For example, there's at least 5 or 6 people who have worked full-time at different times or another on getting modules implemented in the Visual C++ compiler and through the tool chain, and that's likely to continue. So it'll vary by feature, but take a look at what the whole team is doing intentionally, and that it's a supported production feature in the compiler. That's really the statement of support and of resourcing, because that extends for many years in terms of support and updates way beyond the initial implementation.
Thank you, Herb. I would like actually to dive a bit deeper into the static exceptions. So if you could maybe share, how do you think when we'll get the zero deterministic exceptions, and also how will these deterministic exceptions be used in the standard library? Will there be two versions for each throwing functions, or how it's going to be prepared there?
So the status is that since 2 years ago, the major thing I wanted to find out was, is this an acceptable direction that the committee would be willing to entertain to solve this problem and to solve it in this way? So the problem hypothesis and the solution hypothesis. And the committee overwhelmingly said, yes, we want to solve this problem. And the committee gave strong, not universal, but strong encouragement to, yes, please do more work to pursue this general solution. But there were like 4 major parts of the proposal. That was for 3 of the parts of the proposal. And in particular, here are technical questions that you need to figure out and fix for compatibility. So with that encouragement, now comes the time to prototype it. So the next step will be, over the next year or so, I hope to come up with at least 1, maybe 2 prototype implementations in a major commercial compiler or 2 of static exceptions, to validate that it can solve the problems that it aims to solve and address the feedback we've got so far. Once we do that, the time will be to come back to the committee. And then the last question about the standard library, how will it use it? We'll pick that up then, because first we have to validate that this solution works, and then we can look at, okay, what does this mean for implementations of the standard library, including especially making sure that we keep a strong backward compatibility tie to bring C++ developers forward with whatever we choose to do.
Thank you. Can you tell what exactly was the problem with contracts which stopped them from arriving in C++ 20?
So contracts is something that everybody understands is important and everybody wants. And to get them into the C++ working draft in the first place required a compromise. People basically discovered late that the compromise wasn't quite what they wanted. It didn't satisfy one group in one way, and it didn't satisfy another group in another way. So the short answer is just the feature wasn't quite baked yet. It needed a bit more bake time. And so because we ship on this train model, where the trains leave the station every 3 years, that gives us a great release valve. We just say, hey, any feature that's not ready for this train, don't worry. The train will leave the station without it, and the next train is already in the station, ready for loading as soon as the previous one leaves. So there's always another train. So what we're doing now is taking a step back and working through to converge again on the requirements for contracts and what people want out of them to solve those problems, and just bake it the rest of the way. And I have pretty high confidence that we'll see it in perhaps even the next standard, but certainly the next standard or 2. And I know there's active work continuing with contracts. It's well along. Now we have to bake it the rest of the way.
Thank you, Herb. We actually have a very practical question from the audience regarding the C++ 20. So which version of Visual Studio will support C++ 20 fully?
Watch CPPCon. You'll get the latest updates there.
Thank you. So, a question from our audience: why there is no ability to disable some tires in C++ compilers? For instance, a lot of stuff cannot be removed from C++ standard because of backward compatibility. But if I do not use that old stuff, I would be happy to disable some tires in the compiler. Is there any plan to do so?
That's a very good question. It's something that I've been actively thinking about for several years, and so have other people as well. And I think I'm optimistic that in the next few years that we might be able to see some concrete ways to be able to do that. So one of the here, just to give you a sense of how I think about this, one of C++'s primary strengths that has made it successful is the zero overhead principle, the way Bjarne describes it. Now, notice zero overhead doesn't mean that zero cost, like a language feature doesn't cost anything. But what it does mean is that I can't do better by hand. So even if I didn't use the abstraction, I tried to do it myself, I couldn't reasonably do better by hand, and I don't pay for it if I don't use it. I'm being Zoom bombed here. That's our new puppy who just arrived 2 weeks ago. He is a rescue we just adopted 2 weeks ago. So he's sniffing things. That's progress for him. But the zero overhead principle is very important because it gives C++ the ability to give efficient abstraction. I don't pay for things if I don't use them. And if I do use them, I can't do better by hand. So we violate that in a couple of places. We violate it with exception handling, which is type erased, which I don't need most of the time, but I pay for it even if I don't use it, and RTTI. But largely, C++ sticks closely to that principle. Now coming to your question, this isn't quite the same thing as the zero overhead principle, but you can think of it as saying, what if we applied the zero overhead principle at a language level, at a compatibility level, meaning that I always have perfect backward compatibility, which is super important for adoption, for going back to the first question in this session that we talked about. Compatibility with our previous version is super, super important. But what if there was a way to have that compatibility in a zero overhead principle way where I pay for it only if I use it? And if I don't need backward source compatibility in this translation unit, in this source file, is there a way that I can make C++ simpler in that source file if I don't need to be able to include any random header written in the last 40 years? So that's something that I've been giving a lot of thought to, and I'm optimistic that's something that perhaps we can make progress on in the next few years. It's something worth trying out, but I think it's worth at least conceptually thinking about it as, hey, what if I applied the zero overhead principle, which we know and love in C++, to backward compatibility, which isn't the kind of thing it's normally applied to, but you can sort of maybe squint and see where in principle it applies in a similar way.
Thank you, Herb. By the way, very nice dog. Yeah, indeed. I would like actually to talk a little bit about the standard library. So with the recent language evolution, the standard library, it evolves naturally as well, and it gets many new types and many new functions. But by the end of the day, it looks like language committee, at least it looks to many people, that the language committee is trying to fit everything into the standard library, like the whole world. So, and it scares the newcomers, and it hardens the times for those who are with the language for quite a long time. So instead of adding all these maybe not very basic things into the standard library, do you think that maybe it's better to like cook some other libraries, maybe certified as well by the committee, but they are not exactly in the STL?
So I gave a talk at Going Native back in 2012, 2013, where I showed the relative size of the C++ standard library compared to the .NET and Java standard libraries. Spoiler, the difference was 2 orders of magnitude. We are still not anywhere close to that. So I don't think anybody should be worried that our standard library is too big. In fact, until we have things like JSON and networking and HTTP in the standard library, we don't have a sufficient standard library, in my opinion. We're getting there, though. We have a lot of important things. So that's the first thing. I do not think at all we need to get as big as .NET's and Java's standard libraries. That's actually undesirable. The experience of those languages has been that they kind of wish they didn't have such big libraries now because of maintenance burden and the cognitive load of learning all of that. So I'm not saying we should be that. They're too big. I'm saying that we're still not quite big enough. And things like JSON and networking are examples of that. Having said that, an important feature that C++ is only now starting to develop the muscle for is package management. And if you have a better way of acquiring libraries than doing a Google search and figuring out how to install each third-party library in a different way, and then we're in a much better place. And when we see VC Package, Conan, and those kinds of efforts, yes, they're still not quite at the apt-get level or of the cargo level of usability, but they're way better than we had 5 years ago, and they're making great progress in that direction. So that also relieves the pressure to jam a lot of stuff into the standard library by having a well-known set of community libraries and an easy way to be able to actually consume them. So I do think the standard library still needs to grow some more. But I think that the growth in libraries can be both in the standard library and also through package management for C++ libraries. Modules indirectly helps quite a bit with that by getting away from some of the complexities of the pound include header build model that we inherited from C. So I look forward to seeing that continue to progress. It's on a good trajectory, and I look forward to seeing that continue to progress with package management and modules, and the C++ standard library itself growing over the next 5 years.
Thank you, Herb. What do you think about the no-except modifier and its overhead to size of binaries?
So I think the no-except modifier is great, except like most C++ modifiers, it should be the default. You should actually have a not no-except or a throws opt-in, but we can't do that immediately for backward compatibility reasons and just language history. But you will notice that in my P709 value-based exceptions proposal, one of the things it talks about is opting in. It's starting to build a path to where we could get to having most functions be no-except and opt-in. The overhead you're talking about is the overhead that we require a no-except function to check if an exception actually is about to leave the function that we call terminate. And that requires a branch in the generated code. I think this is overblown in terms of its cost, though. I have seen measurements of this cost that I think are incomplete. In particular, you can show that, yes, the code gen for that function is larger, and that called in certain ways, you can measure an overhead to that check. However, no-except allows you to do optimizations of call sites that you could not otherwise do. And once you take into account the fact not only that the checking part of no-except does add some overhead sometimes, but that the presence of no-except lets you get rid of other overheads and do other optimizations. The comparisons that I've been seeing more recently that take those optimizations into account show that it's actually making binaries faster. So that's something where research is still being done. But I think the right way to think about no-except is that it will help us to make our code faster, because the compiler will have to be less defensive about potential exceptional control flow paths when they don't have to happen. Now, of course, we'll really see the benefit of that in some future world when we get to the point where a majority of functions can be no-except. We're not there yet today. But even with a minority of functions being no-except, we are already in a place where no-except does make programs faster much of the time. So when you look at those measurements, make sure you're measuring not just the cost on the individual function, but also the cost across functions where no-except lets you get optimizations that we can't otherwise achieve.
Thank you, Herb. And one more very practical question, I would say, like, how can we force the transitivity of const? So there are examples where const, for example, const function call changes the object. So can the language prohibit calling non-const class function members in some way?
So there's two aspects to this. One is const cast and one is deep const. So just the const cast, if I call a function that takes something by, say, const reference, and then it casts the const away and modifies it, don't do that. Turn on your C++ core guideline rules that say, hey, that doesn't compile. We flag that. Because, it's like reinterpret cast. Somebody can reinterpret cast and do something unsafe and fiddle with bits. So I think a valid answer there is don't do that. The interesting technical question is, what about deep const? And I do not have an answer for that. It is not something I've looked at deeply, no pun intended. But I do know that the people who have not yet come up with an approach that makes const deep without looking at the broader question of immutability. So I think that a solution in that area is going to make progress on immutability generally, including the question of taking mutable objects, a tree of mutable objects, and freezing them. That's a term that's often used, that basically transition them to become now immutable. Once you have an already immutable or a frozen and now immutable graph of objects, that's deep const. And that's a very practical form of deep const. That compilers and optimizers and concurrency checkers can work with. So I think progress is likely to be made in that direction. In terms of actually just having deep const qualifiers that just say, oh, on this path, the object may still be non-const on other paths, but on this path, I'm going to treat it as const. I'm not familiar with a lot of progress in that area, but I think if you go beyond that to actual immutability and immutable slices of things and regions, there's promising work to be done there that has worked well in other languages.
Thank you, Herb. A question about, starting C++ 20 and beyond. After Scott Mayer stopped his work on C++ teaching, what books would you recommend to learn modern C++ features?
So there are several good ones. Nico Yosudis, Rainer Grimm. There are several good ones that are out there. Definitely Bjarne's A Tour of C++, second edition, which is being kept up to date with the standard as it evolves. And I believe, I cannot speak for him, but you may ask him about, say, how's the third edition going for the C++ 20 features. But certainly the Tour of C++, second edition, and Yosudis's, Grimm's, and books like that are very helpful in learning what's new in the standard. And I'm sure I'm forgetting a couple, so my apologies to the people whose names I should be remembering right now and are not in my mind, but those are three examples.
Thank you, Herb. There is actually a question from our audience about the probabilistic programming, if you've heard about the concept. So, and do you see it can work for C++? So Eric Lipper talked about this technique several years ago in the interview. So maybe you've heard something and can comment on that?
I have heard of it. I don't know enough about it to be able to give a good comment about it.
Thank you. So, talking about the committee work, how does work go on in this in current COVID situation?
So the committee, obviously, we're not meeting face to face right now, and we're not going to until it's safe to do that. So, in the meantime, the committee has already been doing work via telecons in subgroups. So even besides individuals getting together to work on their proposals together on a particular area, subgroups have been meeting. So for education, for SG14, for low latency, gaming, and real-time systems. And what we've been seeing since the COVID situation started, so since the Prague meeting, is we've been having more telecons, including for the first time actual telecons for the two main design groups, the language evolution design group and the library evolution design group. And so we're currently continuing to work on how do we make those even better, but they have been meeting weekly. And They've been giving feedback on proposals, and as a next step, we're going to be looking at seeing over the course of the rest of this year how we can actually make decisions on things like progressing the proposals to go to core language and library language specification wording to be actually put into the C++23 working draft. That's something we've never done without a face-to-face meeting before, but it's something that maybe we can do starting later in the year, even without face-to-face meetings. But as far as face-to-face meetings go, we're all in the same boat. We have to put safety first. We are all watching the news, and nobody can predict what's going to happen. The only thing I can predict with certainty is that we are not going to meet face-to-face again until it's legal to do that, so that countries and companies loosen travel restrictions. But more than that, that it's safe to do that. I think it would be a tragedy if we convened a meeting and somebody felt that they had to attend because we were having the meeting, even though they didn't feel safe attending. We want to have a pretty good degree of certainty that we can focus on the technical work. No technical work is more important than our health. And as much as we love C++, we love our loved ones more than that, and our communities. So I think that's the right priority to have. In the meantime, turns out that Teams and Zoom and Google Meet and such things, ISO provides the Zoom account for us, Zoom accounts for us all to use, has been very productive, and it's basically pushing us in a direction we were already going, and just gave us a bit of a push to explore it more aggressively and sooner. So it'll be interesting to see how that is going to develop further this year. It's already progressed quite a lot. We've been doing much more than we ever have online in these last 3 months.
Thank you. It seems soon we'll see like some kind of these C++ online standard work results. So, and what's the main focus for the committee right now? Is it C++23 already, or is it still some bug fixes for C++20 in the progress?
It's both. It's primarily C++23. So we've actually been doing C++23 work for several years as we've been working on features we knew wouldn't make C++23, just like the image I showed, those long pull features that we work on all the time, even if they don't make the next train. But as you get closer to each release, the fraction of work that you do on the old standard versus the new standard just adjusts. And now that we've shipped the C++20 standard, it means we're almost done with it. And by almost done, what I mean is that the C++20 standard is done. It is cast in stone. It's going through its final ISO red tape right now and approval balloting, but it is technically done. However, like any product, once you ship it, we will fix bugs. And so we still are finding bug level things that we want to fix, including as defect reports that are retroactive to C++20. Every standard does this kind of thing all the time. You don't do a lot of it because most things you just fix in the next standard, but some things that are worth fixing and amenable to fixing in the previous standard can be applied retroactively. So that, for example, compiler vendors can retroactively do that in their C++20 mode. And so we found a few of those, and we're working on those, but largely we're looking forward to post C++20 now, C++23, further reflection TS work, that kind of thing.
Thank you, Herb. There is another question from the audience. Do we really need ISO for C++? There are a lot of restrictions in C++ standardization process since it's done under ISO umbrella. Lack of transparency, strict restrictions for publishing C++ standard for free, and many others.
So those things are true. There's a balance here. Remember that when we get together for standards meetings, you have people from all the major tech companies who build C++ tools and use C++. They get together in a room and decide what C++ will be. If this were not done through a standardization organization, that would be collusion and fall under antitrust law. So antitrust law has a specific exception where, yes, all the companies in an industry are allowed to get together and collude and decide on what they're going to do in a coordinated way for standardization purposes. And even then, we're not allowed to talk about marketing. We don't talk about product plans or prices or any of those things. Those are prohibited. So those are, and we remind people, don't discuss that. Don't tell us what you're going to ship when. We don't talk about that at standards meetings. We talk about the technical part of it. If we were not with ISO, we would have to be under a different standard settings organization. So the usual term standards development organization, SDO, or standard setting organization, SSO, you need one of those to be able to operate legally and do what we do in a way that everybody knows is being done in an honest way and is not really a bad form of collusion. So please don't lose sight of the fact that ISO gives that transparency. The fact that we are in an ISO process gives you the transparency of saying, this is not nefarious. This is above board and it's being done for the good of the community. Now, you might say you might get that through an open source project as well, and that's often true, yes. But especially in this case where you have vendors collaborating this closely, which you want so their products work together and the code is portable, this is an important and good structure to have. Now, having said that, I think that when people hear that ISO is closed, it is not as closed as you think. It's certainly not for C++. So technically, ISO rules say you can't even have non-members in the room, but the convener, which is me, is allowed to invite experts, and I do all the time. We also work co-located not just as an ISO meeting, but as a US Insights standards meeting. And because of that, we operate under both sets of rules, which allow us to do things that you couldn't do if you were just under one set of rules, such as invite observers. So every single standards meeting, we have had more and more people who are not members who are welcome to come and join and see what's happening, even without having paid a membership fee. As far as the actual final standard, yes, ISO makes their money somehow, and one way they do that is by charging national bodies to be members, so the nations pay, and also by charging for the standard. Having said that, you can get drafts of the standard and proposal papers. All of our documents have always been publicly available except for the final text of published standards. So I'm not sure how much more open we can be, given that ISO is allowing us to do those things. Hopefully those things are useful to the community and they're linked from prominently on the isocmp.org website. There and on openstd.org, you will find all of the standardization proposal papers that have ever been written and be able to grep them, to read the rationale. And so we hope that's very useful reading for those who want to know more about what's going on in standardization. And we're looking at ways to make it even more transparent, but I hope that that might help sort of see the benefits of being under ISO that we would have to have under some standards umbrella, no matter whether it was ISO or somebody else, and the openness that we do already have. And hopefully that's something that will benefit people.
Thank you, Herb. There is a question from one of our listeners, which he really wants to ask you, is why some study groups in C++ committee seems not really active nowadays, and here meaning the HD6 numerics, for example.
So numerics actually is active. So there are some study groups that are not currently active, like databases, SG11, and most are currently active. We actually have 23 active subgroups right now, most of them study groups. The ones that are not active are primarily ones that have completed their work. For example, the modules study group was inactive for a while because it had completed its work and the work had progressed into the core subgroups, into the main subgroups. Now, since then, we've looked at doing more modules work, and so we've actually reopened the modules group. David Stone is chairing that, and so that's been helpful for us to continue to, when there's now a new wave of modules work, we can reopen those groups again. One that's not currently open, another example, one that's closed, is concepts. Not because concepts is no longer important. It is. They're in C++20, but it's because they're done, and there's not active further work being done that needs to be incubated. Primarily, most of the study groups are for incubation, so it's good to think of them in that way. And so when you see a feature make it into the main standard draft, of course, it's going to be out of the study group because it's no longer been incubated. It's already been brought into the draft standard. But SG6, I believe, are working on a numerics TS as we speak. So that one in particular is doing at least some work. And if you want to find out more, you can always send mail to Lisa Lippincott, who is the chair of that study group, and she would be able to give you the latest status of what numerics is doing.
So, is there any numeric TS in the nearest future? Will we see any TS on numerics in the nearest future?
I know that there's one being actively worked on. I don't know how close they are to being able to ship a draft of that.
Thank you, Herb. Let's talk a little bit about the C++ Foundation. So, as it states on the site, it's a non-for-profit organization whose purpose is to support C++ software developer community and promote understanding and use of modern standard C++. So, what does exactly the foundation do, and how does it practically support the community?
So, by far, the most expensive thing the foundation does every year is put on CPPCon, and to professionally record those videos and make them available for free every year to the community, to try to make the high quality current content available, and to set a bar for all C++ conferences. And we're glad to see many, including yours, ACCU, and others, also doing professional recording, and that we didn't have as regularly before CPPCon came around, and make that material available to people following and learning C++ on places like YouTube and Channel 9 and places like that. So CPPCon is the most expensive thing we do. We also do grants to help standards proposals. So there have been several standards proposals that would not have progressed if it hadn't been for grants from the foundation. And we generally don't advertise those, but there are several features in C++ 20 that would not have been there without grants by the Standard C++ Foundation to help fund them continuing. Otherwise, the authors would not have been able to continue, and nobody else would have continued doing the work. But because they were worthwhile, they had been encouraged by the committee. So it's not just the foundation is not picking winners. It is not, the foundation is not saying, this is the proposal we want to see. The foundation makes funds available so that the committee's chairs can tell us when there is a need for a proposal that has been encouraged by their group that will not otherwise make progress, and they put together a grant request and so far we've been able to fund almost all of those. And so again, it's being driven by the committee. It's not by the foundation. That's explicit to make it clear that it's not the foundation deciding what should be standardized. We're just trying to help the committee. Another way that we help the committee is that every meeting for the last several years, we have funded multiple people who would not have been able to attend otherwise. And these are people who are not just, a random attendee or a first timer, but somebody whose proposal has been encouraged and is not going to make progress in a subgroup unless they're able to be at the meeting, and they just can't afford to be. Their employer won't send them, or they're not don't have an employer who will send them. And again, the committee chair has requested travel assistance for them. And so we've been able to help them to attend meetings. And again, we've been able to get progress in proposals we would not otherwise have had because the expert wouldn't have been able to travel to be at the meeting. And finally, several of the last couple of years of meetings, probably at least the last 5 years of meetings, quite a few have been entirely funded or partly funded by the Standards Foundation, the Standard C++ Foundation. And so having those tools available, all of them are intended to help and serve Standard C++, not to say what it should be, but to say, hey, how can we help in a financial way the committee to do its work with meeting hosting, travel for experts who couldn't otherwise attend, and even grants to help proposals progress that the committee has said that they want to see progress. And then make CPPCon be an industry event that it has a professional recording of over 100 talks every year and lots of other material to make high quality material about C++ and today's current C++ available widely throughout the world to publicize what the committee is doing. So those are the main things that we've been involved with. And I say we because with one hat on, I chair the C++ Standards Committee. But here I've been speaking with my other hat on, which is that I'm also the chair of the Standard C++ Foundation, which is a separate thing. And what the foundation does is in service of what all the committee chairs do. It's not just something where I pick anything. And the directors, including myself, Michael Wang, Chandler Carruth, Roger Orr, and Bjarne Strustrup, all of us feel very strongly that even though we're all prominent in ISO standardization, we're not deciding where grants go. So if you look at the isocpp.org about page and it talks about our grant policy and those things, you'll notice specifically that the directors don't get to vote as to who they get applied to. We're just trying to administratively make funds available that the committee can use and that the subgroup chairs, of which we now have 23 of them, can decide what will help for progress in standardization and help us to do things that are good that otherwise wouldn't have been funded properly.
Quite a short question. What is your attitude to introducing syntactic sugar to C++, like ranges or lambdas? Don't you worry that it can increase the complexity of the language?
It definitely can. It's a short question, so I'll try to give a short answer. Sugar is great when it's not magical, and it lets you make something feasible that wouldn't otherwise be feasible. So, for instance, lambdas is an example you gave. I can write all those function objects by hand. It's just syntactic sugar for function objects. But Lambda makes it so convenient, and to have a piece of code locally here in the scope without having to go somewhere else and define a separate class and do it all by hand. So it's conciseness and locality that even though it's just a sugar, it gives me something I would not otherwise have. It gives me an expressive power. The main thing I want to, as long as we do that, we are delivering clear value. The thing to avoid is having two ways to say the same thing. Now, arguably, lambdas is that, but qualitatively it's not, because you simply couldn't use by hand written function objects as conveniently and in line in a piece of code at all otherwise, because you just can't write function objects on the fly in an expression without lambda support in the language. But really, it is important to resist just doing too much of sugar, where you end up having two ways to say the same thing. And the two ways have different knobs and options. And they're usually compatible, but sometimes they have divergent meaning. Those are bad things to avoid. So a little sugar goes a long way.
Thank you, Herb. So it's nearly the end of our interview. And to wrap up, I actually want to ask you the very, very last question is, how is your piano progress going? We all enjoy your playing at CPPCon.
Well, thank you. I appreciate people's tolerance for the mistakes, but I'm playing at home now. We've been in quarantine since the beginning of March because we actually got quarantined even before Seattle had its quarantine, which was one of the earlier ones in the United States, because we had come in contact with some ones we knew. So it's been 4 months. It has been 4 months. Yeah, it's been a third of a year now we've been in quarantine. So I've been having some practice time. But the main thing is that when I've been the one, I'm guilty, to make sure we always have at least one and usually more public pianos available at CPPCon, which are mostly played by other people. I love listening to other people play. We have a great number of talented people, and just having that kind of musicality and that option available in the hallway at CPPCon, where regularly people are just stopping and playing a tune or three, is just part of the cultural atmosphere that I've always wanted CPPCon to have and enjoy very much. And I get to use the piano 2 or 3 times in the whole week of CPPCon as well. But mostly I enjoy listening to other people. We have many talented people. There are always dozens of people in the week who are playing there, including people who aren't attending CPPCon. We had another professional convention last year where in the same building was a police and firefighters convention. And so here are people in uniform sitting down because the piano was in the area they were crossing and sitting down and playing a tune. And it was really nice to see.
Oh, great. thank you, Herb, very much for your awesome interview. We really appreciate your time. It was very interesting. Thank you very much.
you.
And
Thank you very
Thank
much for
you.
having me. It's great to see C++ Russia online, and большое спасибо.
oh.
Oh, you're very welcome.